Hello friends, welcome to lecture number 2 of partial differentiation. Okay, today we're going to learn how to differentiate partially and we're going to solve these three questions. Here you can see. Okay, so before we start, please subscribe the channel, hit the thumbs up button, also share with your friends. It's for me to create new contents for you. Okay, support me to grow my channel. Okay, and if you want to follow me on Insta, this is my Insta ID, that is Oza OJHA Likhajit LAKHYAJIT 123. This is my Insta ID. If you want to follow me, then you can follow me. Okay, we have a function of two variables. Z is a function of, suppose, two variables x and y. Suppose you are asked to differentiate partially, if you are asked to differentiate z partially with respect to, suppose, x, then derivative of f with respect to x, suppose let it be f of x, then here we're gonna consider y as a constant. Consider y as constant, right? Suppose let's say, for example, I have z is equal to sine x square plus y square. Okay, then here you see, just wait, I will take this one later. First let me take this example, y into sine x, suppose. Okay, so if you need to find the derivative of z with respect to x, partial derivative of z with respect to x, then we're going to take this y as a constant, so we're going to differentiate this part only. That's going to be cos x. That's it, right? Now you see, suppose z is equal to, suppose let me take another example, suppose y sine x square y, suppose x square y. Okay, so then here you see, if you differentiate it with respect to x partially, then y should be taken as constant. Derivative of sine x is cos x, so here we're going to write cos x square y. Then as it is function of function, so that's why again we should differentiate this part, which is within bracket. Here you see, as you can see here, x square into y, but don't apply the multiplication rule, because this u into v rule, don't apply this one, because here you see we are differentiating with respect to x, and partially we are differentiating partially. So when you differentiate a function partially with respect to x, then this y should be taken as constant. Okay, so then what we're gonna get, if you differentiate this x square y, then you're gonna get 2xy, right? You're gonna get 2xy. Now what if you suppose, let me take this one only, let me take this function only, this one only, sine of x square y. So if you need to differentiate with respect to y, then what we're gonna get, again derivative of sine x is cos x, right? So here we're gonna get cos of x square y. Now we are differentiating with respect to y partially, so we can take as it is function of function, so we're going to differentiate the function within bracket as well again. So when you differentiate this one, now this time we have to consider x as a constant. Take x as a constant as we are differentiating with respect to y. So then what we're going to get here, so the dx of this is now cos x square y into, if you differentiate, if you consider x square as constant, then it x square and derivative of y is 1, right, with respect to y. So you're gonna get this result. So here you can observe that, just wait, this part is same, doesn't matter with respect to which variable you differentiate, but when you differentiate the function of function, this function which is within bracket, its derivative there is depending on the variable with respect to which you are differentiating partially. Okay, but this part is same, right? So that means if you have a function like this, suppose z is equal to, if you have a function f of x square, or suppose f of g of x, function of function, suppose f of g of x. Okay, then if you differentiate it with respect to x, then its derivative, what will be its derivative? That f dash of g of x. Again you need to differentiate this g of x partially with respect to x, right? So hope you have understood this. So now let me clean these things. Let's solve few problems. Now how to solve this question? Here we have z cube thrice yz minus thrice x is equal to 0. We need to find z, we need to show this two are equal. Okay, so z into del z by del x is equal to del z by del y. So first, so what is the given function? Let me write here. Z cube minus thrice yz is equal minus thrice x is equal to 0. As we are going to find first let us find del z by del x. Okay, if you partially differentiate it, this is suppose equation number 1. Differentiating, just wait, differentiating equation number 1 with respect to, first let us differentiate with respect to x partially. Okay, let us differentiate partially. So now here we are differentiating partially with respect to x. So if you differentiate this, so 3z square, according to this formula, we are going to use the same formula that we used in total differentiation, that is x to the power n is n into x to the power n minus 1. But here you see, though we are differentiating with respect to x, but it is not only x, so that's why again we need to put del z by del x here, then minus. So here we're gonna consider y as a constant because we are differentiating with respect to x, then partially, so 3y, then del z by del x, then minus. Then if you differentiate x, that's going to be 1 into 3 is 3, simply equal to 0. So here you see we can divide both sides by 3. Okay, if you divide each and every term by 3, then you're going to have z square del z by del x minus 3y del z by del x. So 3 is cancelled now because we have divided by 3, right? So then minus 1, that's going to be equal to 0. Now let us take this del z by del x term common, then what we're going to get, so z square minus y into del z by del x is taken common, minus 1 going to be plus 1 on the other side. So from here what we have got, del z by del x is equal to 1 by z square minus y. That's what we have got. So now let me clear this. Okay, now what we're going to do, let us differentiate equation number 1. Now let us differentiate equation number 1 again with respect to y. Differentiating equation number 1 with respect to y partially. Again we're going to apply the same method. Here this is z cube, so 3z square, then del z by del y this time, then minus. So here you see we have to use the product rule here, because now we cannot consider y as a constant because we are differentiating with respect to y. So 3, if you use the product rule, that is derivative of product of two functions, first function derivative of second function plus second function derivative of first function. If you apply that, considering y as a first function, z as a second function, then first function derivative of second function, that is del z by del y, then plus, because of this minus, that plus going to be minus, then 3 derivative of y is 1 into z, then derivative of this one going to be 0, because now we are going to take x as a constant because we are differentiating with respect to y. So that's why this derivative of this term with respect to y is going to be equal to 0. So that's equal to 0 now. So now what we can do, again we can divide both sides by 3. Then we're going to have z square minus y, this is taken common, this one is taken common, del z by del y, then this minus z on the other side is going to be plus z, right? And both sides are divided by 3. 0 divided by 3 is 0, right? So hope you have understood. And from here what we're going to get, we're going to get del z by del y is equal to z by z square minus y. That's what we have got. So here let me take this one as equation number 2. Sorry, one already we have used. So let me take this one as equation number 2 and this one as equation number 3. So now let us copy these two results and let me go to the next slide. Okay, so we have got del z by del x is this, and let me copy this one as well, third equation, and we have got del z by del y is equal to this. So we are going to use these results now. So what we need to show now, we need to show that z into del z by del x is equal to del z by del y. We are to prove this. Okay, so first let us find this one. So in equation number 2, if you multiply z on both sides, then what you gonna have? Equation number 2 into z, that's gonna give you z into del z del x is equal to z into 1, that's gonna be z. So if you multiply z here and here also, then you're gonna get this result, z square minus y. So this is nothing but equal to this one, right? So from equation number 3, what we can write, z into del z by del x. So this can be replaced by this value, right? So hope you have understood this, del z by del y from 3. So this one is done. So second thing, what do we need to show, and we need to prove one more thing, that is z into second order derivative of z with respect to x and y, then plus del z by del x whole square is equal to second order derivative of z with respect to y. That's we need to prove. Okay, we have to prove this one. So to prove this one, what we can do first, as we need del to z by del x del y, so that's why what we're going to do, we're going to differentiate this with respect to x again partially. Okay, so now differentiating equation number 3 with respect to x partially, then what we're going to have, then we're going to have del x of del z by del y, right? And on the right hand side we have z by z square minus y, that should be also divided, not divided, differentiated. We are going to differentiate this one also with respect to x. So we are differentiating this equation number 3 both sides partially with respect to x, right? So now here we're going to apply this rule, derivative of u by v. Okay, so denominator derivative of the numerator minus numerator derivative of the denominator by denominator square. So here the denominator is this, right? So what we're going to get now, so this implies del to z by del x del y is equal to, on the other side, denominator is z square minus y and derivative of the numerator is z, and we are differentiating with respect to x, so del z by del x minus numerator is z, and derivative of the denominator, that means ddx of z square minus y divided by denominator square, that is z minus y whole square. That's what we have got. Now let me copy this and let me go to the next slide. So let me take this step. Okay, so here is the last step we have got, right? So now let's simplify this. So how to simplify this? Del z by del x, we know this value, this one, this is the del x by del z. So if we put this value here, then what we're going to replace, just wait, let me write these equations again. Let me write the equation number 2 and 3 here also. Let us replace this by this one. Then what you're gonna have, so z square minus y into 1 by z square minus y. So the, right, so this 2 gonna be cancelled, minus z into, if you differentiate this, then you're gonna have 2 into z, then again we are differentiating with respect to x, so del z by del x, then minus this minus, and because of this minus, that's going to be plus, and if you differentiate with respect to x, then that's going to be 0, so that's going to be 0, right, divided by denominator square z square minus y whole square. So now 1 minus 2z square del z by del x divided by z square minus y, z square by minus y, z square minus 1 minus y whole square. So here let me mention, I have using equation number 2, right? So here I have put the value from equation number 2, right? So hope you have understood this. So now what we are going to do, and what we need, we also need this one. Let me go back to the previous slide. So also we need this term, del z by del x whole square. So it's very simple. Here you see del x by del z, this one. So if you square both sides of equation number 2, you're gonna get that. So squaring this equation number 2 on both sides, squaring equation number 2, if you square it, then you're gonna get del z by del x square, and on the right hand side you're gonna have 1 by z square minus y whole square. That's what we're gonna have. So now you see what we need to, so this one, this is the left hand side. Okay, here we need to multiply z as well, and we need to add these two. Okay, so what do we do now? So first what we're gonna do here now, so let us add this one and this one, then what we're gonna get, therefore del 2z by del x del y plus del z by del x whole square. If you add this on the right hand side, these two also should be added, left hand side plus left hand side, right hand side plus right hand side. So what you're gonna get, 1 minus 2z square del z by del x divided by z square minus y whole square, then plus 1 by z square minus y whole square. That's what we're gonna have. Okay, that's fine. Okay, now if we take LCM, then what we're gonna get, here is the LCM, right, and in the numerator we're gonna get this result, right? 1 plus 1, that's gonna be 2. So let me write straight away as this is as 2. Okay, that's what we have got. Then you see, let me go back to the previous slide again. We need to multiply z here, okay, to show this one, right? So let's multiply z. On multiplication of z on both sides of this equation that we have got now, we're gonna get this result, and 1z should be multiplied here also, then it's gonna be 2z minus 2z cube del z by del x divided by z square minus y whole square. So that is what we have got. Now let me copy this and let me go to the new slide. Okay, so this is the last step we have got, right? So we need to prove that this is equal to what? So let me go back to the previous slide. We need to prove this one. This is second order derivative of z with respect to y. So we need to prove this is equal to this. So that's why let's find this one. Let's find this. Now you see, if we replace this value del z by del x using equation number equation number 2, del z by del x is equal to this one. So let me use this one here. Then what we're gonna get? We're gonna get this result. Just wait. So we're gonna get this result. So we're gonna have 2z minus 2z cube. So that will be divided by z square minus y divided by again z square minus y whole square. That's what we're gonna have. So here what we have done using equation number 2, right? So this is the equation number 2, right? We have used this equation. Just wait. So this is the equation number 2. Let me copy this 2 and 3 because we need these equations frequently. This is 2 and let me write the 3 as well. So this is equation number 3 here, you see. So this is equation number 3. So this is the equation number 3. Okay, so now we need to prove according to the question this part is equal to this one, second order derivative of z with respect to y. So let's prove this. So from equation number 3, what we are going to do, we are going to differentiate equation number 3, differentiating equation number 3 with respect to y partially. Then what we're going to have, del y of the left hand side, that is del z by del y, then del y of right hand side, that is z by z square minus y. So here we're going to apply this rule, u by v. Derivative of u by v is v into derivative of u minus u into derivative of v by v square. So here z is u and this one is v, denominator is v. So that means denominator, that is z square minus y, into derivative of the numerator, that is del z by del y, then minus numerator, that is z, then derivative of the denominator, that is z square minus y, its derivative, divided by denominator is square, that is z square minus y whole square. That's what we have got, right? So on the left hand side it becomes second order derivative of z, second order derivative of z second order derivative of z with respect to y. So now let me simplify this. So what you can do here, so let me z square minus y del z by del y minus, if you differentiate this, that's going to be 2z. So if you multiply it by z, then that's going to be 2z square. Then here this is minus y with respect to y. If you differentiate, that's going to be 1. Okay, that's going to be 1. Then if you differentiate this y, right? So this minus, that's going to be plus on opening the bracket. So plus 1. That's what we can have. And one more thing to be added, as we are differentiating z with respect to y, so that's why we need here del z by del y, right? divided by the denominator square, that is z square minus y whole square. That's what we get it. Okay, now again we're going to replace this value from this equation number 3. Okay, so if we do so, then what we will have, so let me write here. Okay, so here what we're gonna have now, so z square minus y into, so this value z into z square minus y minus 2z square, again z del z by del y is replaced by z square minus y plus 1 divided by the denominator square, z square minus y whole square. That's what we have got. So now these two cancels, so as a result we can have this. And one more thing, I made a mistake here, that is this z should be multiplied with this one also. Differentiating y, we have got 1 into z, that's supposed to be z actually, that's supposed to be z. Okay, so hope you have understood this. Now just wait, let me clean these things. Okay, so then what we're gonna have, so here we have got 1z, there is 1z, z plus z, 2z, so that's going to be 2z minus, and z into z square, that's going to be z cube, 2z cube divided by z square minus y, but the denominator is z square minus y whole square. That's what we have got, and this result is same as this one if you see clearly. So we have got these two are also equal. So let me give this is equation number 4 and this is equation number 5, right? So from equation number 4 and 5, let me copy these two equations and let me go to a new slide. So this is the equation number 4. Let me paste the 4 here as we're going to use, and equation number 5 is this one. This is the equation number 5 we have got. So this is the equation number 5, right? So from 4 and 5, what we have got, this is equal to, just wait, this is equal to this second order derivative of z with respect to y. So hence it is good, right? Because both the results are same we have got. So now let's move on to the next question. Now let's solve this question. So here what we have u is equal to log of x square plus y square plus tan inverse y by x. That's what we have. So we need to prove this relation. So first let us do one thing. First let us find del u by del x. So del u by del x, that's going to be equal to, if we differentiate it with respect to x partially, then we know ddx of log of x, that's going to be 1 by x. So here instead of x we have x square plus y square, function of function. So that's why again you have to divide this partially. If you divide this one partially, then this time we're going to take y as a constant, so we're going to have 2x only. So let's put the 2x here, right? Then plus, and here you see ddx of tan inverse x is nothing but 1 by 1 plus x square, right? ddx of tan inverse x is 1 by 1 plus x square. If we use that formula, then it should be 1 by 1 plus y by x whole square. As it is function of function, again you need to differentiate it. So y by x, if you differentiate it with respect to x, then here it should be considered as derivative of y x to the power minus 1. Here y should be taken as constant because we are differentiating partially. So in that case, and derivative of x inverse is nothing but minus 1 by x square. So it's going to be minus y by x square, right? So here we're going to write minus y by x square. That's what we have got. So hope you have understood this. So now let me clean these things. And let's multiply the denominator and numerator with x square. Sorry, by x square. Then what we're going to have? So then we're going to have del u by del x is equal to 2x by x square plus y square, plus here we're going to have minus y x square plus y square, and taking LCM, del u by del x, that's going to be equal to x square plus y square will be LCM. Then here numerator is twice x minus y. That's what we have got. Now in order to get the second order derivative, let us differentiate it again. So then what we gonna have? Therefore second order derivative of u with respect to x, that's gonna be, now consider this one as u by v. Okay, so the denominator, that is x square plus y square, derivative of numerator ddx of 2x minus y, that's going to be 2 only because derivative of x is 1 and derivative of y, that's going to be 0 because when you differentiate with respect to x, y should be taken as constant, right? Minus numerator, that is twice x minus y, then derivative of the denominator, derivative of this, that's going to be twice x, and derivative of y going to be 0 with respect to x, right? When you differentiate partially, then x square plus y square whole square, denominator square, that's what we have got. Okay, now what if you multiply, if you simplify all these things, then what you're gonna have? So 2x square plus 2y square minus 2 to the 4 x square, then this minus plus 2xy divided by denominator is that is here in this case x square plus y square whole square, right? So here it becomes 2y square minus 2x square, because 2x square minus 4x square is minus 2x square, then plus twice xy, that's what we have got, divided by this, right? So this one we have got. Now let me copy this result and let me go to the new slide. So this is what we have got, second order derivative of u with respect to x, that's what we have got. Now let me go back to the previous slide. Now let us find this one, this term. So in order to find it, we need to differentiate this with respect to y. So let me take this again, just do it. So now if you differentiate with respect to y, then again derivative of this, that's going to be 1 by x square plus y square, and derivative of this x square plus y square with respect to y, that's going to be twice y, so that's going to be twice y, right? So similarly, if you differentiate this with respect to y, tan inverse y by x, then derivative of this, that's going to be 1 by 1 plus y by x whole square. Then if you differentiate this with respect to y, 1 by x, that's going to be constant, and derivative of y is 1, so here we're going to get 1 by x. So here it can be replaced by this result, 1 by x by 1 plus y by x whole square, right? So we have differentiated this we have differentiated this one with respect to y, right? So hope you have understood this. Now let's multiply here x square, and denominator, in denominator also multiply x square. So then what you're gonna have? So your result gonna be del u by del y 2y by x square plus y square, and plus here we're gonna have x, then x square plus y square, right? If you multiply here x square, that x square gonna be cancelled by x, right? So only x left. So hope you have understood this. So now take LCM. So let me clean this things. Take LCM. So x square plus y square. So here twice y plus x. That's what we have got. So if you differentiate it again with respect to y, then considering u by v, then denominator, that is x square plus y square, derivative of the numerator. So if you differentiate the numerator with respect to y, then you're gonna get 2 into y. Derivative of y is 1 and derivative of x gonna be 0, because we are taking y, x as a constant, because we are differentiating partially with respect to y. Then minus numerator, that is 2y plus x, then derivative of the denominator. If you differentiate this with respect to y, then you're gonna get 2y, right, divided by denominator is square x plus y, x square plus y square whole square. That's what we have got. Now let's differentiate this, simplify this one also. Twice x square plus twice y square minus 4y square, then that's plus minus, that's again it's gonna be minus 2xy. That's what we have got, right, divided by the denominator is square x plus x square plus y square whole square. That's what we have got. Okay, so now from here, second order derivative of u with respect to y, that should be equal to subtract these two, that's gonna be twice y square minus twice, not this one. So if you subtract these two, then what you're gonna get, twice x square minus twice y square, then minus twice xy divided by that x square plus y square whole square. That's what we have got. So now you see, this is equation number, let me take, this is 1 and this is 2. So adding 1 and 2, okay, adding 1 and 2. So let me copy this equation number 1. So this is the equation number 1. Now let me go back to the previous slide to copy the equation number 2. So this is the equation number 2. So here is the equation number 2. If you add these two equations, equation 1 plus equation number 2, then what you're gonna have, you're gonna have second order derivative of u with respect to x plus second order derivative of u with respect to y, partial derivative. Okay, then here let me add this one plus right hand side of equation number 2 as well. Left hand side plus left hand side, right hand side plus right hand side. So if you take LCM, then you're gonna have x square plus y square whole square, and then 2y square minus 2x square plus 2xy, then plus 2x square minus 2y square minus 2xy. Here this term is gonna be cancelled, minus 2xy plus 2xy plus twice x square minus twice x square minus twice y square plus twice y square. That's gonna be 0 by x square plus y square whole square. And if that is the case, 0 by anything is 0, so that's why second order derivative of u with respect to x plus second order derivative of u with respect to y, that's going to be equal to 0, hence proved. So hope you have understood. So let's take the last question for today. Now let's solve this problem now. So here z is equal to y into f of x square minus y square. So here z is equal to y into f of x square minus y square. So now you see, we need to prove this one. So as I have already given this example, that if you have, suppose if this f of x square minus y square is suppose sine of x square minus, let me give you an example, sine of x square minus y square. Okay, now if you differentiate it, if you differentiate it with respect to x, suppose, okay, if you differentiate it with respect to x, suppose, right, f with respect to x, so its derivative, that's del f by del x, then you have to differentiate this as well. Okay, let me consider, as you see, if the derivative of sine is cos x square minus y square, and if you differentiate this, it is function of function with respect to x, then you should get twice x, right, twice x here. So since you see, as the derivative of sine is cos, so similarly let us consider that derivative of this f is, suppose, f dash of x square minus y square, and if you differentiate this function of function, that's going to be twice x. Let me consider that way. Okay, similarly if you differentiate it y with respect to y, then again derivative of sine with respect to y, here you're gonna get again cos of x square minus y square, and derivative of this term, which is within bracket, that's gonna give you minus 2y, right, minus 2y. Let me cos x square minus y square and minus 2y, that's what we're gonna have. So here you see, that means what we're gonna get if we differentiate with respect to y, then f dash x square minus y square, then again here we're gonna have minus 2 as well, right, minus 2 into y, right. Hope you have understood this, minus 2y, that's what we're gonna have. So here you see, so it doesn't matter with respect to with respect to x or with respect to y, if you differentiate partially, this part in both cases, when you differentiate it with respect to x and y, both part becomes same. So when you differentiate the function inside the bracket, then you get different results here, right. So this part, this common part, we have considered f dash of x square minus y square, right. So just I have given this example that's gonna help you help you to understand better this problem. Okay, so first let us differentiate z with respect to x partially. Then here we're going to use the product rule, sorry, not product rule, because we are differentiating with respect to x, so we're going to consider y as a constant. So constant is taken outside, and derivative of f of this is f dash of x square minus y square, and differentiate this function which is within bracket, then it's gonna give you 2x only, right. Now if you differentiate it with respect to y, then what you're gonna have, then you see, now we are differentiating with respect to y, so this is y and this is function of both x and y, so that's why here we're gonna use the product rule. Okay, first function, derivative of the second function, that is f dash x minus y, then as it is function of function, so it's going to be minus twice y. If you differentiate the term within the bracket, minus twice y, because we are differentiating with respect to y, then plus second function, that is f dash x square minus y, sorry, now second function, not derivative of second function x square minus y square, and derivative of the first function, that is y, derivative of y, that's going to be 1, derivative of y, that's going to be 1. So this is what we have got. So if you simplify this, then you're going to get f of x square minus y square, and here minus 2y, so we're going to get minus 2, just wait, minus 2 y square f dash of x square minus y square. That's what we have got, right. So hope you have understood this. Now here you see, as we need y into this, so let's multiply y on both sides, then what you're gonna get, y into del z by del x, and here twice x into y, then again y, that's gonna be 2xy square, 2xy square, that is f dash of x square minus y square, right? Similarly, in the second term, this x should be multiplied with this, so let's multiply x here and here as well. So doing so, what we're going to have, x into del z by del y, x square minus y square, then 2xy square, right? 2xy square, f dash of x square minus y square, right? So now let's add these two. This is suppose equation 1, this is 2, adding 1 and 2, adding 1 and 2, what we're going to have, 1 plus 2, so y del z by del x plus x del z by del y, left hand side plus left hand side, right hand side plus right hand side, twice x y square f dash of x square minus y square, then plus right hand side of equation number 2, x into f x square minus y square minus 2xy square f dash of x square minus y square. So here you see these two terms cancel, right? So now what we have got, let me go to new slide. So on the left hand side we have got this is the left hand side, right? And on the right hand side, what we're going to get, so we're going to get x into this one, so we have got this. Now you see from the given information from this one, so now let me copy this, just wait. As it is given that z is equal to this one, so here from here we can write f of x square minus y square is equal to z by y, right? Z by y. So if we use this result here, then it's gonna be y del z by del x plus x del z by del y, and here we're gonna get x into z by y. So this is replaced by this value. So let me write here this one here, since so this is what we need to prove, right? So hope you have understood this. So if you like my video, please hit the thumbs up button, also share with your friends, inspire me to create new contents for you. See you in the next video. Stay connected. Bye bye.